So here's another one of these um, somewhat deceptive integrals where if we look at it, we might say to ourselves, well, I'm pretty sure there has to be an antiderivative formula for this function, but there isn't. We know how to take the derivative of the inverse sine function, but we actually don't have a formula for the integral or the antiderivative of the arcsine. So similar to the way that we approached the integral, the ln of x, when we set this, the u and the dv up for this particular problem, since we don't know how to integrate the inverse sine to begin with, we're really kind of just letting dv be equal to dx, which leaves for our u the inverse sine, which is fine because, as we mentioned, we know how to take the derivative of this. So we'll go ahead and we'll do that to get our du, and the derivative of the arcsine is 1 over the square root of 1 minus x squared dx, and then the antiderivative, or the integral of dx, is just going to give us x. So armed with this info, let's go ahead and set up our integral. So this integral will be equal to u times v, so x times the inverse sine of x minus the integral of v du. So that's going to be x times 1 over 1, the square root of 1 minus x squared dx. Okay, so this one's got a fun little facet to it. So we know that we've got x inverse sine of x right here. So how are we going to integrate x times 1 over the square root of 1 minus x squared dx? Well, it turns out that this is going to require u substitution. So we're going to take this one off to the side and do a u sub. And if we were to let, and I know this gets confusing because we've already picked a u and a v, so if you want to pick a different letter, that's fine. Maybe we'll do a w substitution. So we'll let w be equal to 1 minus x squared, which would make our dw negative 2x dx. So we've got a little bit of modifications to make here. So if we divide both sides by -2, we'll have negative 1/2 dw is equal to x dx. And now we've got our pieces for our u substitution, or excuse me, our double u substitution over here. All right, so we'll carry this through. You could either bring this back over, or maybe you could take care of it now. I think I'm going to just do our u sub right here. So this would give us the integral of negative 1/2, and then we've got 1 over the square root of w dw, which would just be negative 1/2 times the integral of w to the power of negative 1/2 dw. And if we integrate this, let's see, so we'd have negative 1/2 times, so if we add 1, it's going to be multiplied by 2, w to the power of 1/2. And if we replace our w, that's going to give us negative 1 minus x squared to the power of 1/2. All right, so we're going to go ahead and we're going to replace that integral with this value right here now. All right, so just to kind of recap what we've done here, we started by doing a integration by parts, and in taking the integral of this term right here, we noticed that we had to perform a u substitution, and that gave us this result down here. So we're now going to bring this back up to the rest of the problem. Give myself a little space here. All right, so now we've got minus And then this result, which was negative, and I'm going to write this as the square root of 1 minus x squared. And then we've got our plus c. So we can just clean this up really nicely and write this as x times the inverse sine of x plus the square root of 1 minus x squared plus c. So this is great news. You know, we might think that these integration problems just have one facet to them, but no, we can have integration by parts and use substitution working the same problem, which I know is great news for us.